So as you see, these blue elements, they're all metal. The yellow one, you're on non-metal. Sulfur is a non-metal. Selenium is a non-metal. Bromine is a non-metal. Iodine is a non-metal. And blue ones are metal. What about the green ones? They're called metalloid or semi-metal. That means they have half properties of metals and half properties of non-metals. So what do we know? What are general properties that we know about metals? Well, we just saw. Most of them are on the left-hand side of the table. Example of metal, copper. Is copper a good conductor of electricity? Yes. Is it a good conductor of heat? Yes. Are they shiny? Metals are shiny. Are they ductile? Can you bend them? Can you make wire out of them? So these are properties of metals. How about non-metals? Well, let's check. Do you see non-metals? Except for hydrogen, non-metals are mostly on the right-hand side of the periodic table. And what do we know? They are dull, they are not shiny, they are brittle. You hammer them, they will break to pieces. Or metals, you hammer them, they are ductile, you can make a plate out of them. They don't break into pieces. While metals are excellent conductor of electricity, non-metals are poor conductor of electricity, and they are being used for insulation. So how about metalloid, which have mixture of metallic and non-metallic properties? Well, let's look at one example. Did I say metals are good conductor of electricity? Metals are good conductor of electricity. Did I say non-metals are poor conductor of electricity? Look at silicon. It's a metalloid. It is semiconductor. So their properties is half and half between the two properties of metals and non-metals. So go, guys. Can you fill in the blank? Stop the video and come back. Do these make sense? Did you get them right? All right. How about these ones? You're reviewing, you're refreshing your memory of these things that you learned in previous courses, Chem 2A or high school chemistry. Did you get the right answers? Yes or no? I hope you did. So guys, as I said, this chapter we are going to talk about measurements and units. Again, you have taken these before, so I'm just reviewing to refresh your memory so you can do future chapters which involve unit conversion factors. So as we said at the beginning of this chapter, we said the purpose of chapter 1 is reviewing the material you already know, you have taken it. And we also said measurement is important part of the science. We do a lot of measurements in science. So that's where we were. I'm going to start by discussing the units of measurement. Right. So we are going to talk about units of measurement, a refresher for you. You have taken these, but I thought I may refresh your mind. So as you said, as we said before, there is a lot of measurement in science. So when you do a research, when you do a work, you publish the work for the rest of the world in international communication for other scientists to use the result of your work. So we want to be able to communicate our measurement in a single unified international unit that everybody can understand. As you know, in this country, we are measuring length in inches and feet and yards. Rest of the world, most of the world is measuring the length in meter. So we call international unit as SI unit. So when we talk about this SI unit in measuring the distance, international unit is using meter. So the metric system is international unit. And the abbreviation for meter is M. SI unit, which is Système International in French, which is international unit for measuring the mass. The mass is explained in kilograms, although you measure mass in grams and micrograms, but in scientific paper, when you're reporting, you report it in terms of kilograms. If you're measuring temperature, you measure temperature in this country in Fahrenheit, but scientific system is using Kelvin. We have taken different temperature scale. You have seen at them before. International, most of the metric system is using Celsius, and Celsius is easily convertible into Kelvin. I'll give you the formula pretty soon. And in chemistry, you might remember, if I want to show amount of the substance, I'm going to use mole. And you probably remember how to convert grams of anything to moles, but I'll probably do a review problem for you. So the unit of mole is abbreviated as MOL. And for measuring the time, you can record time in hours, in days, in seconds, in minutes, but international system is using seconds. The abbreviation is S. And for measuring the electric current, international unit is using ampere, and abbreviation for ampere is A. And to measure intensity of the light, which is luminous intensity, the unit is in candles, and you abbreviate it with CD. So now let's take a look at the units, international unit of measuring the volume. As you see, I have got a cube here. Look at the dimension of the cubes. It's 1 meter by 1 meter, and the height is 1 meter. So if I multiply these 3 units together, is it fair to say that I get 1 cubic meter? So 1 meter times 1 meter times 1 meter. That's how you calculate volume of a cube. You get 1 cubic meter, right? And if you pay attention, this is this is 1 meter. This length is 1 meter. And if you count, you're going to see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blue cube. The measurement of this cube is 1 deci, 1/10, 1 decimeter. So can I say this cube, which is 1 decimeter by 1 decimeter by 1 decimeter, is 1 cubic decimeter. And if you count number of these blue cube here, you'll see 10 by 10 by 10, a total of 1,000. So can I say 1 cubic meter is 1,000 cubic decimeter? 1 cubic meter is 1,000 cubic decimeter. And if I look at this cubic decimeter, if you count, you're going to get 10 cubes here, 10 cubes here, and 10 cubes here. 10 times 10 times 10, you get 1,000 of these cubes. Each one of them have a dimension of 1 centimeter by 1 centimeter by 1 centimeter. Is it fair to say that 1 cubic decimeter is 1,000 cubic centimeter? In other words, there is 1,000 of these cubes in 1 cubic decimeter and 1,000 of these cubic centimeter in 1 cubic meter. So is it fair to say that 1 cubic meter is 1,000 decimeter? And 1 decimeter, which is 1,000 cubic centimeter, is 1 liter. And you have heard milliliter, that's what you do in the lab, it's 1,000 of a liter. And 1 milliliter is the volume of this cubic centimeter. So 1 cubic centimeter is the same as 1 milliliter, 2 different names for the same amount of volume. So I'm going to give you a table on exam which relates these units together.